Assalamualaikum dear viewers, Shoaib is here with another lecture of the electrical machines, and today we are going to discuss the armature reaction in the DC machines. So the armature reaction in a DC machine can be defined as it is the action of the armature flux on the main flux, okay. So that is called as the armature reaction. Already we know that there are the two windings in the DC machine. One is the field winding and second is the armature winding. The field winding in the machine in a DC machine is responsible for production of the magnetic field in which the armature is rotates, and in the armature conductors the working EMF is produced. So whenever the armature of a DC generator is rotated with the help of external prime mover, so what happened, the lines of the cuts of the flux takes place, and according to the Faraday's law of electromagnetic induction, whenever a flux is linking with a coil is changes, an EMF is induced in the coil. So when the generator is loaded, so the current flowing through the armature conductors creates another magnetic flux, so that is called as the armature flux. Okay, we have assumed only the magnetic flux acting in a DC machine is that due to the main poles, so that is called as the main flux. Magnetic poles are responsible for the production of the main flux in the DC machines. However, the current flowing through the armature conductors also create the magnetic flux, so that is called as the armature flux. So whenever DC generator is loaded, the currents which are induced in the armature conductors, so they are responsible for the production of the magnetic flux. So that magnetic flux can be called as the armature flux, because this flux is produced within the armature conductors, and that distorts and weakens the main flux coming from the poles. Now this is the action of the armature flux on the main flux. Whenever the generator is loaded, the currents are induced in the armature conductors, so that magnetic flux which is produced in the armature conductors, so that is called as the armature flux, and that distorts or weakens the main flux which is coming from the main pole. So this is the armature reaction, that armature flux distorts or weakens the main flux which is coming from the main poles of the DC generator of the DC machine. That action can be called as the armature reaction. So the distortion and the field weakening takes place in the both DC generators and the motors, okay. So the action of this armature flux on the main flux, this is called as the armature reaction. Armature reaction in a DC machine can be explained by these three diagrams. So number first diagram shows when the generator at the no load condition. When the generator at the no load condition, in the armature conductors they are generating the maximum induced EMF within it, okay. So now the phenomena of the armature reaction in a DC generator is shown in figure. Only one pole is shown for the clarity. When the generator is on no load, so a small amount of the current flowing from the armature conductor does not appreciably affect on the main flux, which is the phi 1 coming from the poles. You can see this is the one pole shown for the clarity, and this is the tips of the poles. Number 1, A is the leading tip of the north pole, and B is the trailing tip of the north pole. So you can see the equal flux distribution takes place when the generator is on the no load. So what happened, only the flux which is acting on the armature conductors is due to the main poles which is coming from the main poles. Now the second point, when the generator is loaded, so now what happened, the current flowing through the armature conductors sets up the flux which is the phi 2 as shown in figure, okay. Now when the generator is on the no loaded condition, only the flux which is acting on the DC machine is due to the main poles, and that flux is called as the phi 1, okay. As we know that the generated EMF in the DC generator is directly proportional to the flux per pole, okay. So now in the case of the no loaded condition of the DC generator, a small amount of the current is flowing from the armature does not appreciably affect on the main flux. So that's why in the no loaded condition the generated EMF will be maximum. But when the generator at the loaded condition, the current flowing through the armature conductor sets up a magnetic flux, okay, due to the armature reaction, so the generated EMF in the loaded condition of the generator will fall because of the armature reaction. When the generator on the loaded condition, what happened? The armature conductor sets up the flux phi 2. Now this phi 2 flux is sets up because the armature conductors that carries the amount of the current which is flowing through the armature conductors, and that sets up the flux which is the phi 2. So this figure shows the flux due to the armature current alone. So now by superimposing the phi 1 and the phi 2, we will get the resultant flux which is the phi 3, which is shown in this figure. So now refer this circuit diagram, okay, this circuit diagram, figure number 3. As you can see, this is the leading tip of the north pole and this is the trailing tip of the north pole. You can see due to the armature reaction, so the phi 3 is the resultant flux, okay, which is produced. So what happened? The higher flux density you can see is on the trailing tip of the pole B. So it is clear that magnetic flux density at the trailing tip pole B, point B is increased, okay, while at the leading pole tip A is decreased. It is due to the armature reaction. So this is the unequal field distribution takes place because of the armature reaction, okay. So now this unequal field distribution which produces the two possible effects in the DC machine. Number first is that the main flux is distorted, because when armature of a DC machine in which the amount of the currents are induces in the armature conductors, so the flux is induced in the armature conductors. So that is the magnetic flux, that is the armature flux, and that distorts or weakens the main flux coming from the main poles. So this effects can be called as the distortion or the weakening effect, or normally called as the armature reaction in the DC machine. So first point is that the main flux is distorted due to the armature reaction. Number second point is that due to the higher flux density at the north pole of the pole tip B, the saturation sets in, okay. Now as you can see, trailing pole tip of the B point, okay, so you can find out that this flux density is higher, and at the leading pole tip A the flux density is lesser. So now compare this phi 3 with the phi 1, so we can conclude that this phi 3 is less than the phi 1, and this phi 1 is the flux which is produced when the generator at the no load, a small amount of the current flowing in the armature does not appreciably affect on the main flux. So this was the armature reaction. Now let's discuss the geometrical neutral axis and the magnetic neutral axis. So what is the geometrical neutral axis? So the geometrical neutral axis is the axis that bisects the angle between the central line of the adjacent pole. Clearly this axis is the axis of the symmetry between the two adjacent poles. So that is called as the geometrical neutral axis, which is normally termed as the GNA. Second one is the magnetic neutral axis, normally termed as the MNA. Okay, so now this is the MNA. So the axis drawn perpendicular to the mean direction of the flux passing through the center of the armature. So this is the armature, okay. So now this line draw perpendicular to the mean direction of the magnetic lines of the forces they are passing from the poles and crossing the armature. So clearly no EMF is produced in the armature conductors along with this axis, because then they cut no flux. So when MNA coincides with the GNA, so clearly no EMF is produced in the armature conductors, okay, and also they cut no magnetic flux. So with no current in the armature conductors, the MNA coincides with the GNA. In order to achieve the sparkless commutation in a DC machine, so brushes must lie along the MNA. So dear viewers, this was the lecture regarding the armature reaction, okay. So if I am going to summarize the lecture, What is the armature reaction? The armature reaction can be defined as it is the action of the armature flux on the main flux. So that is called as the armature reaction. The flux which is produced in the armature conductors is distort or weaken the main flux which is coming from the main poles. So this is called as the armature reaction. I hope that you have enjoyed today's lecture, and at the last, do subscribe my YouTube channel Shoaib for more informative videos related to the electrical engineering area. Thank you.